Hey, hello engineers and welcome back to the DevSecOps series again. So today we will be discussing about what is SCA, Software Composition Analysis. In the previous videos, we have discussed a lot about security fundamentals and architectures, and we also have seen what are the different types of scans do we do. So let's go to our YouTube channel and see what are the different topics we have covered. And you know in the last video we have discussed about SAST, okay, and what do we do in SAST, and what are the different tools that we get to see in SAST. So you see we have covered the topics of security fundamentals, introduction to DevSecOps, and the principles and most important concepts and all these things. What is threat modeling, stride, RAID, pasta, and what is SAST, and what are the different tools that are used in it. So you can go to this particular series and check the previous videos before moving ahead from this point, because unless and until you know all this stuff, it is very difficult for you to get the holistic picture of what security brings into when we talk about DevSecOps in the SDLC. Then you can also see that we have started a new series which is related to the AWS, and in it we first have discussed what we are going to cover in this particular series. So over here you can see what are the different topics we are going to cover. Okay, and this is the list of content that we can see over here. And okay, also you can navigate to the GitHub account that we have to get the PDF of all of these things. So here you can find the PDF of the DevSecOps series, wherein whatever the slides that I am currently sharing with you guys are over here, and you can download it with one click. As well as you can go to our YouTube channel, then the AWS series DevOps playlist, as well as these are the different topics that we have covered, as well as the interview questions. Also, you can see the new upcoming AWS series. I'll be uploading the content over here related to the AWS series. So, okay, let's do the deep dive in the topic that we have today, which is about the SCA. Let's first see what we are going to discuss in this particular topic. So, first of all, what is SCA? As I mentioned, software composition analysis, but not just the abbreviation. We need full definition of it, what it does. Okay, so we'll get to know about it. Then, what do we do in SCA? So, what kind of analysis is it? And then, what is the difference between the previous one that we have learned, SAST and SCA? Because this is a kind of interview question that a lot of people fail to answer, as I have experienced in my own case as well. Because before I was aware about DevSecOps and all the different methodologies, I too got confused between what is the basic difference between these two. Okay, SAST and SCA. They look same, but they have different tasks. Okay, so I mean they do scan different things. The end result is the same. They gives us the vulnerabilities and how to mitigate those vulnerabilities, but what is it going to scan? That is the difference between them. So that's the intro question. Then we will see what is the market having a different kind of tools. So we will see about 10 different tools, let's say, for example, and we can try one or two of them. I will demonstrate you how to use them in a later video, and then you can once you have a hands-on experience of one particular tool, then you can always try different tools, just to add it to your bucket list. So the major thing here you need to know is about what is SCA. How to do it is a different case. Okay, so enough of it. Let's begin our today's topic. Cyberblade. So first of all, as we mentioned, software composition analysis. So what is the meaning of it? Okay, software is one thing. Composition, it means what is it composed of, and analyze that particular thing. So SCA is a process used to identify and manage open source and third party components or libraries, okay, that are included in the software application. So, whenever you start writing code, you kind of write some import statements, okay, or use this using, okay, in terms of C sharp. So, if you have done C++, you do hashtag include, okay. So, what are we doing? We are kind of importing certain libraries into our project, and then we are consuming them as a part of our code base. So first of all, in SAST, what we use to scan is what you have written as a code base. Okay, what lines of code you have written. That is what we scan in SAST. But in SCA, you scan the imported libraries or third-party components that are used in your application. So not everyone, like let's say you want to do JSON deserialization or serialization. So you don't go there and write a particular code for that, how to do it. What you do, you import a serializer, and then you just pass into that particular function this particular JSON file or JSON data, and then it deserializes it based upon that. Okay. So these are the different kind of libraries that you kind of consume in your application, and that's the thing that we are going to see. Now there are different versions of this particular packages or libraries. Is there any vulnerability in them? How are we supposed to know? Okay, so that is the reason why SCA is done. So the primary goal of SCA is to, oh sorry, R2, I'm not sure. Primary goals of okay, multiple goals we are talking about are to ensure first security, compliance, and quality of software product. Okay, so how does it ensure security? It checks your libraries or third party components and tells you if they if that is licensed component or that is publicly available, the source or the origin of that particular or the maintainers of those particular libraries are bound to provide the list of vulnerabilities that are outstanding in this particular libraries or third party components. So once your application will do what, it will scan uh, with this particular available data that we have, and then it will tell you is it secure or not. If it is not secure, then it will ask you to upgrade it to a newer version where these issues are fixed. And once you upgrade to that function, your application by default becomes compliant to the regulations that are there. Okay, cybersecurity regulations or security regulations, and then it ensures the quality of software that you are building is intact with it. So that is why, let's say, if I give an example of tomato ketchup. So, what is it made up of? Can you list down these things? So you see, first is the primary goal is, I mean, primary ingredient is tomato. Then there would be salt. Then there would be some, preservatives. Then there would be some color additives. Again, then there would be some water that goes into it. So these particular SCA tools will check what ingredients are there. The final output is the ketchup, but what is it made up of? That is what will be analyzed. And now, are these tomatoes which are used in your ketchup of good quality, or they are of like they were black or they were blue in that case? Okay, when they are too much ripe, that becomes tangy in taste or sour in taste. So this is how it does. Now, if the water which was used in your ketchup, making of your ketchup was good or not, okay, was it from a filtered source, or was it directly like unprocessed water which was used? So this is how it uses. I mean, you can think about SCA as checking the ingredients of any software components. The same goes with SBOM, but SBOM is literally listing out all these things and showing you which versions of these things, I mean, these particular components or libraries are used. So we will see there is a similarity between SCA and SBOM in this manner. They do what? They list out the ingredients, and now SCA will show you if there are any vulnerabilities in your applications and if you can fix them. That is the difference. So next is what does SCA do? So as I mentioned, first of all, it will identify the components. Okay, so SCA tools scan the code base to identify all the open source and third party libraries. So by now you must have got this thing into your mind, like third party libraries. and different components that we use. This is what is been accessed in the SCA, which is used in your software. And then this includes both the direct dependencies and the transitive dependencies, libraries that are dependencies of other libraries. So let's say, uh, you know, there is one library that you consume. Now, this library also depends on, I mean, it might have also consumed another library. So now the particular this one direct dependency is your direct dependency, and the other one which this dependency has used is a transitive dependency. So it will check for both the vulnerabilities in both the particular dependencies, transitive as well as direct dependencies. So that is one thing. Again, you can consider it as a mutual friend. Let's say there is one friend of yours, and then there is another friend of your friend. Now, then, what is the relationship between you, your friend, and that another friend of your friend? You are mutually, correlated. You are not directly a friend, but it is a transitive friendship that you have, mutual friendship that we say. So then, next is what is vulnerability detection. So as I mentioned, SCA tools would check the identified components against databases of known vulnerabilities. So now first it will identify what are the components that are used in your application. The next step is to check them against the database of known vulnerabilities such as the National Vulnerability Data (NVD) as we have discussed it earlier. If you don't remember where we have discussed, you can check some another videos wherein we have talked about it. I will list it over here, wherein we discussed about CVE, CWE, and all these things. Then the common vulnerability and exposure lists, CVEs, you can see it over here. And then it checks these databases against whatever the list it have created, and then it identifies any security risk associated with this component. Okay, so once you got to know, okay, the water that is being used in my ketchup was, bought from a certain local vendor, or let's say some small town. I'm not sure if that is safe or not, if that is processed or not. Okay, let's say I didn't wanted to use the word gutter, but let's say gutter का पानी अगर use किया है, then that is really, okay. I don't want to talk about it. So next is what license compliance. So now SCA also tries to help listing out the licenses of whatever the components you are consuming. So in that way, SCA helps organizations ensure that they comply with the licensing requirements of open source components that they use. So in an organization, let's say you really need to, sorry, I forgot to do it over here. So you need to comply with certain regulatory bodies, and they show you like if you are using licensed components, then only you can serve your software to use for the users in our region. So that is the reason licenses are really important. Once you are licensed, then they can be sure, okay, yeah, we don't need to worry about our data. We don't need to worry about security much as they are licensed. They should be complying with things. So that's the reason. Now, different open source licenses have different obligation, and SCA tools can help track these particular requirements. So that is a major benefit of using an SCA tool. You don't need to explicitly, um, you know, create something out of the box to, help comply your solutions. Then quality assessment. Some SCA tools also assess the quality of components, looking at factors such as maintenance activities, community support, and frequency of updates. So now, uh, you know, quality is really important. And then if there are any, let's say if there was some vulnerabilities in previous versions of certain package, are they updated? Is there any, new version available? So it also checks for that, and it suggests you if it finds a new version. Then now, if you are using a vulnerable component, then you can upgrade it to certain newer version, and then you can be sure that these vulnerabilities have been fixed in the another version. So that is what maintenance activities would it would look at. Then it would see for community support and then frequency of updates. So that's a general case. So then reporting and remediation. Now SCA tools also typically provide reports that summarize the findings. Now Once you have found out that there are 1,000 vulnerabilities in my application, now what to do? You need to create a report and you need to share it with your stakeholders, the development team, the product owners, product managers, and all these users that you have made. If you are kind of sharing this information with them, so if that is the case, SCA would help you summarize these things in a particular report, including any vulnerability or licensing issues, and it may offer recommendations or for remediations as well. So as I mentioned, when it suggests you a new version to upgrade, it is showing you a way to remediate this particular vulnerability that is detected. So that is the case of remediation. Now, such as updating to a newer version of a component or replacing it with a more secure alternative. So if there is no new version which have the fixed vulnerabilities in it, then it would try to suggest you, okay, this is not a secure solution. You can check for an alternative one. That's the case. So if no new version, then switch to something else. Now next is the differences between SAST and SCM. So please have a careful attention at this particular span because this could be asked. I mean, it is majorly asked in DevOps or DevSecOps interviews, so that you know people would get to know if you really understand the difference between different security methodologies or different tools that we use on a day-to-day basis. So here you can see what are the different features. What is the difference between SAST and SCM? So what does this tool focus? SAST tools focus on proprietary source code for security flaws. Okay, it would check for code base and then find out vulnerabilities in it. Now SCA analyzes the third party tools or open source component for risks that are available. Okay, so you get the difference between both of them. One is looking at code, one is looking at the libraries that you are using. That's the difference. Then now what it scans is your application code and here external libraries and dependencies. Okay. Then detection is it is doing code level issues, logical flaws, input validation errors, etc. is what been detected in SAST. It shows you weaknesses of your code, and then it suggests how to harden your coding practices. Okay, how to make it hard for someone to inject any flaws or inject any uh, you know uh, kind of code base or any script in your code. So that is what it detects. Now here it detects known vulnerabilities or outdated package or license issues. So I hope by now I have repeated it so many times that you would have learned it by heart. So now when it's used is that during development or build time, and SCA would be used throughout SDLC, especially at build and deployment time, because we need to make sure that whatever the components that are consumed in my application are really secure and safe. Then now what are the different output examples? Insecure function use, hard coded secrets, injection flaws. This is what kind of found out in SAST scans. That is what it says. What does it use as output? It would give you this kind of outputs. Now what would SCA give? SCA would give vulnerable packages, transitive dependency, and risky licenses. So these are the three things you need to keep in mind: packages, dependencies, and licenses. This is what it will scan for and give you as output. I mean the result, whatever the vulnerabilities are there in the packages, it would highlight them. So now access to source code requires access to source code. Now here it doesn't require the access to source code. It just use the manifest files or compiled packages or package.json in that case, and it would find out whatever it is listed, what are the dependency listed in your package.json files, and it will by using these scanners, it would scan these dependencies and check for the database and then let you know, okay, if you are having this particular dependency in your application, then you have a vulnerable application or third party package used. Then what are the different tools examples? So we will look at the tools as well. So for SAST, we have seen SonarQube, Veracode, Fortify, checkmarks are these applications. Then for SCA, Sneak, OWASP, Dependency Check, Black Duck, and all of these different tools that we are going to see in the future slides. I mean, the not future, the next slides as well. And what is the goal? Secure custom code base is the final goal of this SAST stuff. What is the goal here? SCA, secure third party software usage. So if you use this vocabulary in your interviews, you are sure shortly going to have a green mark or green tick or green flag in this particular question. So you should include these particular points in whenever you face certain questions. I hope you got those things. So now let's see how does SAST or an SCA fits together. So here, I mean not SAST particularly, but SCA only. So here you can see open source package registries are used for whatever technologies that you are using now, npm, node package manager, gradle, maven, go, docker, and all these things. You use open source packages. Then now what SCA would do, SCA would have bill of materials, as I mentioned, software bill of material. Then dependency graph it would check, as I mentioned, direct dependency and transitive dependencies. So if one dependency depends on 10 different dependency, and then those 10 depends on again 5 dependencies, then it would create a graph of this dependency. And we will see it in another example where we will check for OWASP dependency uh, application, and how it can be used or integrated for your software for checking the SCA stuff. So that is I'll link it over here once that is done. So next is license compliance, is what SCA would detect, and then it would give you remediation steps to do that. So what it shows is package vulnerability database. So I would just do a B for it. And then how it does is, it would import your open source package manifests. Then it would see for Git repositories if there are any version upgrades. And pre-flight scanning is done over here in your development pipelines or else cloud runtimes. So these are the different places you can find your SCA tools being helpful for you, and you can integrate it in these particular stages, as well as throughout the SDLC for security scannings. So next is popular SCA tools. Software composition analysis can be done using these different tools over here that I have marked as OWASP dependency check. This is what we'll look at as an example. Also, if sneak is possible to be done using our free account, then we can try that as well. Then JFrog X-ray, Veracode scans, then GitHub Dependabot. So we will check for Dependabot as well. We will see GitLab dependency scanning is also there, which would check your application and then packages of that. Then Sneak is also there. Sonatype and Nexus is the repository in that case, and then Sonatype can be used for to do that. Then Black Duck, Mend, and checkmarks can be used as well. So these are the different things that can be used, or the tools, popular tools in the market. So if you even know one or two of them, how to use them and how do they work, you can get the idea of all of these tools in just few days or few hours, so to say. It doesn't require much. You just need to figure out how to integrate your application with these tools, and voila, you are done. So that's why I mentioned learning the methodology is most important thing rather than the tool. Once you know how to apply a particular methodology or what is included in it, then using a tool is secondary. It can be done in matter of days or hours, let's say, if you are more talented than the average people. So next is I guess last topic of this particular slide, I mean this particular say. So we have almost covered the entire stuff about SCA. There is nothing much else about SCA that you need to worry about. And by this, we have covered the third topic, which is SCA. We have learned what is threat modeling. We have learned what is SAST. We will look at the examples as well, or hands-on practice, how you can, take one code base and, implement SAST can and then implement SCA. This is what we will do in our next videos as well. So that, I wanted to cover the basic principles first. Once you know the theory, then we can move to the practical hands-on. Once you know what is being done, then how to do it is really easy to do. So I guess that's it for our today's video, and I would really like if you guys would share this particular video with your known people, and please do like, share, and subscribe to our channel, as well as uh, suggest me if whatever we are doing is helping you out in any way. So you can ping me on LinkedIn, and you can find me over here on the GitHub. So you can download these particular slides from over here. I will add it later on. I guess SCA is added or not. SCA is not added as of now. So I'll add it, and then I'll commit it over here. You can find it over here, and then you can navigate to our the channel, and this playlist you can subscribe to. Okay. I guess that's it for today's video then. Stay tuned, and in the next videos we will be discussing about the sonar cube, as well as dependency check after that. So it would cover the SAST as well as SCA, and I would urge you in the next videos you should have a practical hands-on experience, so that you can use it in your interviews anyhow. So that's all for today, and signing off. Bye bye, guys.